And welcome to this live stream from the University of Cambridge Museums and Botanic Garden. My name is Richard, I work for the aforementioned organisation, and today we're here at the Botanic Garden. You can probably hopefully tell. If you've watched some of our previous live streams, you'll know that we've been going to the museums, going into their stores, looking at some of the really unusual objects they have in their collections, the things that don't always see the light of day. But today is a bit different because, as I said, we're at the Botanic Garden and we are front of house. We are in their glasshouse range, so we're not behind the scenes so much. And also the, I don't want to say object, the specimen possibly, the plant. The plant, yeah, let's stick with plant. The plant we're going to be talking about today certainly has seen the light of day. So I'm delighted to be here with Alec Summers. Alex, can you just tell us a bit about what you do here?
Okay, so I'm the glasshouse supervisor at the Botanic Garden, and my job is generally to maintain the front public range and also our rear reserve houses as well. Those reserve houses are there to supply the front range, to grow plant material for research, and generally do anything that we require around the gardens. But I think most people will be most familiar with all the front houses.
Yeah, great. So before we go on, I must say if you're watching this, please do share it. We want as many people to see it as possible. Throw in likes, smiley faces, whatever you want really. And if you have any comments or questions, please do ask them. Just write them in the comments and Hannah behind the camera will stop us, interrupt us, or wait for a break and ask your question. So please do ask. So we're here to see Titus. This is the name for your Titan Arum. Can you tell me just a recap of the last few days, the last week, what's been happening around this plant?
Yeah, absolutely. So we're very fortunate to have flowered our third Amorphophallus titanum. We have two plants, so this one's flowered twice. It's a rare event at best. We probably reckon there's been 100 or more flowerings in cultivation since the plant was discovered in the 1870s. We equally are really excited because it is a second flowering on one of our tubes as well. So it's a nice event in that sense because we've taken it round full circle. Yeah. So what we realised was at the end of May that we had a bud developing. At that point we're never sure whether that bud's going to be a leaf or a flower.
Right. Sorry, prior to that you don't see it, it's inside the pot.
So prior to that it had been for the past 13 years in a leaf format for 12 to 18 months. Then it would go dormant, and then it puts up a new bud, and then it's been again in the leaf format. So these are all of these plants behind us here are examples of Amorphophallus species. Not this particular species here. This one has a leaf that stands as tall as the big wooden pole behind me here. Yeah. But they do all the same thing. So when that came through in May, and we saw that bud coming up, we ummed and ahed. We've got a small tuber weight on it, so it's not a massive plant. So we were pretty sure we were going to be looking at a leaf. Right. So we sort of walked away and said, we all were like, yeah, it's going to be a leaf, let's ignore it. And then come the 13th of June, where we see the first incrementation on this wooden pole, we were confident at that point that it was going to be a flower. So it sort of bucked what we thought, because this spadix structure here popped out the top of, there's two large papery structures that go around it called cataphyls, and that spadix structure had popped out the top. So once we'd seen that, we knew what we were dealing with. Yeah. Then, from that point onwards, we would measure it on a daily basis, so as it sort of increased, and we go through a very fast growth period where it's almost putting on about 10 centimetres a day. Oh wow. So we went from 55 centimetres on the 13th of June to 136 centimetres, which is the day it actually flowered on the 26th of June, so that's 13 days, and in that time, you've almost grown, 80, 90 centimetres, it's absolutely incredible. So once we got all that going, we're obviously keen to share that with as big an audience as we can. Yeah. So particularly the Cambridge audience, the community who regularly visit us. And so we aim to open late on the days where it's actually flowering, because that's when it's smelling heavily, and we're getting a little bit of that odour now.
We are, yeah.
And it's also when it looks the finest. So, you know, on the day it actually opens, people were able to watch on the webcam as this structure here slowly unfurled away from the spadix.
Amazing, yeah. So You mentioned the smell. I mean, we have to talk about this, I think. On Twitter, I saw as people have been visiting the last couple of nights. The Botanic Garden stayed open till 10 p.m. and you had a smell sort of exit. So people were describing the smells. I've got a few listed here of residue from a microwave kipper is possibly the strangest one. Cheesy death. I mean, why does it smell like this? What is the purpose?
Okay, so we can all agree on one thing, that it smells pretty horrible.
It does.
But the actual smell that we're getting is so that it can act as a carrion mimic, so it's pretending to be a rotting piece of meat. Mm-hmm. Where it would actually come from in the rainforests of Sumatra, that would be really effective because in the surrounding vicinity there are carrion beetles, and those carrion beetles would be attracted into that smell and duped into believing that they were coming to a rotting piece of meat.
Right, yeah.
Obviously, when they arrive at that piece of meat, their interest is to lay their eggs on it so that their young can feed on that and grow into adults.
Yeah.
One of or something I understand generally from the belief of why it's so big is, I think forensic science has shown that these carrion beetles tend to preferentially go for larger bits of carrion over smaller bits of carrion. So if you're able to pump out a massive scent, you can maximise the distance you cover, and you know it's really an expensive strategy to produce such a massive flower. So you might as well try and get out to as big a distance as you can.
Yeah.
B, you're more likely to encourage those carrion beetles to visit you.
Okay, I see. Right, blimey. I'm absolutely intrigued by this small window that's been cut out at the bottom of the plant. What is the reason for that?
So it seems like quite a desecration of such a beautiful structure.
Yeah.
So we are very keen to fruit this plant.
Right.
So we're very keen to successfully pollinate it and then get fruit. And that in itself is not the easiest process. So for most plants, what you can do is you can take their pollen and you can put it onto their stigmatic surface, so the female parts, and you can get them to produce fruit, so you can get successful fertilisation. In the case of this plant here, that's not actually possible because the plant is not willing to self-pollinate. So what we actually had to do was we had to get pollen careered up from a plant down in Eden. We were really fortunate that plant happened to flower last week at Eden, and so we had to get
That's the Eden project in Cornwall.
Absolutely, and we also got pollen down from Royal Botanic Gardens, Edinburgh. That was frozen at -80, so that's a little bit more lab-based.
Yes. Yeah.
And both those sources of pollen were used to pollinate the flowers. Now, when we look at this structure here, we have a tendency to say a flower, but what we're actually looking at is we're looking at, so if people imagine a foxglove spike, we imagine pushing all of those flowers to the very bottom of the spike, yeah?
Okay.
That's what this is. And then underneath it, we've got this huge leaf-like structure, which essentially is just a sterile leaf-like structure that produces colour to add to the attraction.
I see.
So at the bottom there, what we're looking at is the female flowers, and then above them are the male flowers. So it zones out, it's female and male flowers, and then we have this huge sterile structure up here, which is what's producing the horrible odour, and also it's thermogenic, so it's able to increase its temperature, so it's able to spread that right throughout the rainforest environment.
That's why it heats up.
And yes, so it's probably more to do with spreading the volatiles throughout the rainforest environment and less to do with the fact that the beetles are looking for a warm place to stay.
Okay, right, I see.
We have a question.
Ooh.
Are the queues to get to see it still very long?
No, so during the daytime, people should expect... So we were only going to open for 2 nights, and we've done that now. But during the daytime, people should expect to be able to come in, mill around. We've got our own staff members around to answer questions. So no, people should be able to get straight to it when they enter the site.
Okay, thank you for your question. So I was just thinking that when I've been watching on Twitter, there's been lots of activity and people delighting in the smell, obviously. One thing I saw was Zoology Museum had sent you some examples of the insects that would be attracted to this. Do we have them here? Are they...
I think they're in my office because we've got obviously. They were very kindly lent to us, so the carrion beetles that actually pollinate it, which is a great part of being part of the wider University of Cambridge Museums, actually.
Yeah.
But part of that is that we obviously don't want to do any damage to their collections. Like if we lent them, for example, the Titan Arum, we wouldn't want them to damage that equally. So I think they're nicely, safely locked away in my office.
I thought it would be nice to have been able to push them in front of the camera, but not to worry. So when we came in this morning, it was very interesting actually, because normally the garden opens at 10 a.m. and we don't usually get access at this time, and it was like a hive of activity in here of people, I don't know, sort of cleaning up, getting it all ready for visitors today. And one of the things you were doing, Alex, was actually collecting pollen. Is that right? So could you describe just what you were doing?
Yeah, so not only do we want to obviously pollinate our plant, we also want to provide pollen to those who wish to do that. So what we have to do is, because we just talked about the flowers being zoned into the male and female parts on the structure, they also do that zoning temporarily as well. So the female flowers are mature on the first night, so that when that real smell's wafting away and they're really trying to get the pollinators in, and then the male flowers are mature on the second night. Okay. So last night was the second night. Yeah. The pollen probably was at maximum production about 2 a.m. this morning. Funnily enough, I wasn't in at 2 a.m. this morning. So what we did is we came in this morning and we collected that all using a spatula and Petri dishes. That now was all gone to be refrigerated. That will be sent straight to, for example, our partner institution, Royal Botanic Gardens, Edinburgh, and they will then put that freeze it or dry it down and freeze it at -80, and that will be stored, because I think they're fingers crossed to have hopefully one that might flower later this year. Right. But again, it's really difficult to predict because we don't ever know when those buds first come up whether they're going to be a flower or a leaf. Yeah.
So we have another question. How long before this plant dies off? Is it viewable for many more days? And a cheeky little smiley face.
Well, a smiley face back. And so this plant, if we've successfully pollinated, which we'll know in the next 2 to 3 days, whether that's been, next 2 to 3 weeks, not 2 to 3 days. So we're going to keep it here for as long as that's going down. The actual flowering structure we're looking at, we're probably only looking at for another 2 to 3 days maximum. And it will, the whole structure is now sort of slowly withering and starting to disappear. So it won't look as clean as it did the first day it opened. But what we really hope is people follow the pollination, and if fruits do start to produce, we hope that they're ripe by about December time. That's really our major goal out of this one, because whilst flowering events, we said, are not common, fruiting events are even less common because of all the complications we spoke about. Yeah. So we reckon they're probably, there's been about 10 to 15 fruiting events since it was discovered in the 1870s in cultivation. Okay. So if we do that, then I think that's a really exciting outcome. And also it means that we can share fruit with other botanic gardens. So, we can work together, which is what we're all trying to do. And that maximises the opportunity for people to come and see it, and it maximises the conservation resource of this plant as well.
Yeah. Okay, so you mentioned the fact that we're growing it here in the glass house, and they're native to Indonesia, is that right?
Yes, absolutely.
And so what would the difference be to it being in the wild? So would it be one, say, bigger, or would it be flowering more often? What are the sort of differences?
So this plant, like we said, it's actually from Western Sumatra. It's only found along the Barisian Mountains there in Western Sumatra. It's from tropical lowland forest, so that's why we grow it in our main tropical house. With regards to size, we're probably looking at a small example of it. So this here is 1.36 metres. The tallest one ever in cultivation was 3.1 metres, so it was over double the size of it. The largest tuber, so our tuber here is 13.56 kilograms. Largest tuber in cultivation that I know of was Edinburgh's, Royal Botanic Garden Edinburgh's, and that was 156 kilos. I've seen pictures of them in the wild, and they are much, much larger than this. Right. But I expect they're probably a range of sizes. It's obviously genetic, so some, and it's obviously resource-based as well. Ones with in areas where they don't have necessarily as much moisture or necessarily optimal conditions probably do flower smaller anyway. And then with regards to actually locating them, from what I understand, the fruits, so the red fruits that, if anybody knows Lords and Ladies or Jack in the Pulpit, they're sort of red berries that will go right around this structure here. They're dispersed by birds. But what we generally understand is that you get little tight populations of them. So probably what happens is you get a fruiting event, the majority of fruits fall around it and germinate and grow up, and then every so often you get a long-range dispersal event, obviously a bird eats it, moves it quite a distance, and then you get the same situation where you get another little pocket, and that's kind of what would happen within the forests of Sumatra.
Okay.
We have another question, guys. Okay, so what species pollinate? Do they differ between male and female flowers?
Okay, so the species of beetle, there's two main ones that have been found in, or I can do the genus, I can't do the species, sorry. There's two main genera of beetles that have been found in the flowers. They're both carrion beetles. One's called Dionysus and the other's Creophilus. There's probably more pollinators than that. I would be surprised if it was just two beetle species. But essentially, they're relying on insects that are drawn into carrion. The same beetle the same insects will be relied on to carry, well, the main thing they're going to be is the vector for pollen. So the same insect will be relied on to do the whole process.
Great. Good question. So obviously here at the Botanic Garden there's a beautiful garden for visitors to come and see, but there's also a huge amount of research that happens here. Can you tell us a bit about, because I understand there's been some sort of research undertaken with this particular plant. Can you explain what that was?
Yeah, so we take as much opportunity as we can to make the most of the flowering events we've had. So the first thing we were very keen to do is understand the thermogenesis of the plant, so it's able to produce heat. This huge column structure in the centre is what does that, and we just wanted to kind of understand over a time period how that happens. So we were very lucky that the volcanologists at the university lent us their thermal imaging camera, so that had been on Mount Erebus, so it's just behind you there, in Antarctica, and it's now winged its way here to be present and record the structure. So we did this last time with Tiny. We've done it again with this one. The camera we've got this time has higher resolution, and it will also allow us to compare the two time-lapse sequences. And what that allows us to do is understand where the heat is produced and how it transfers down the plant. Equally, our director has taken samples from the flowers, the male and female flowers, and they've been taken off for further study to understand the developmental biology of those. With regards to other parts like scent and odour, we had looked to try and get us mass spectrometer, but that didn't quite work for us.
What is one of those?
It meant to look at the chemicals that are produced to understand them. But what we equally do is we, obviously, when we flower these things, do a bit of a desktop survey to understand what information people have already fed in. The other thing that we can do, which is really helpful, is better understand the pollination biology. So as long as we document everything we do here, so that it helps anybody at any other botanic garden doing it. And we also look to other botanic gardens to help us with how they do it. And all these records, like the height records and how the rate of growth, are really useful because all that data goes in. And when we collaborate with all the other botanic gardens around there, we're able to use that to better understand the plants generally.
Amazing, yeah. So it's really good to sort of understand that all of that work goes on, because it's often something that's quite reasonably hidden from the average visitor. So, what a spectacular plant! And thinking about, I'm intrigued about being here in the tropical glasshouse, because when I think in the past when I've come here in the winter, it's absolutely roasting in here, and I think it's probably because you've got the sort of heating going and everything. I mean, and right now it feels quite pleasant. How does it work? I mean, what are the conditions that you need to make everything grow here?
So you probably notice the heat in here more in the winter because it's a lot colder outside. So relatively, you are picking that one up. And on a hot day, you'll notice it because whilst we can heat the structure, it's a lot more difficult to lose the heat. But with regards to the tropical houses, we run them at a minimum of 18 degrees C. What we look to do is have a nighttime drop in temperature, so we're probably looking to drop at least between 5 to 8 degrees C at night in comparison to daytime, because as everyone appreciates, as soon as the sun disappears, temperatures generally in any wild habitat would drop. Past that, we keep it as a very moist environment, so as you turned up this morning, things are being watered, and you'll definitely appreciate that it's not dry in here in any format. So our main aim is to try and build the same sort of climatic conditions as you'd find for these plants in the wild. That's not just because we're trying to do it to provide an example to everyone, that's because if we don't provide these conditions, we couldn't grow these plants. So we have things to fight, like the winter months here are very dark, and where plants like this come from, they expect about 12 hours of light and 12 hours of night. It's virtually equatorial, nice high light level. So we have lots of things we have to fight, and then we might be lighter on the watering, or we might change our temperature regime just to balance that out. But at this time, the fact that you feel ambiently pleasant we generally feel, and this is a bit more feeling, if you feel ambiently pleasant, the plants will feel ambiently pleasant as well.
Good, that's nice.
We have another question.
Okay.
So how can you know which flower is male and which is female?
Cool. So when we actually get into the structure, when we look down there, firstly we know that the female flowers at the bottom, the male flowers at the top, but actually if we look at them, when we look at this whole structure here, it's doing all the work that one single flower would do. So it's the flowers themselves have got rid of petals, got rid of their sepals, and literally reduce themselves down just to the sexual parts that they require. So at the very bottom there, we simply have an ovary structure and a stigma, so that the full female complement. And then when we go up above it, it looks a bit like a brain structure, but that's just lots of massively reduced male flowers, and their only job is, because they're not doing any attraction, they don't need to do it, they've got everything around them to do it, all they've got is just the stamens to produce pollen. So like anything, you know, it's put all of its energy into this, so it doesn't need to put its energy into the nice colourful floral bit.
We've got a couple more questions.
Oh, cool. Let's have
Okay, so we've got, how do you propagate the plant? Which I think we talked about a bit, haven't we?
Yeah, I think I can probably help you with that, because both we're going to go for seed and fruit.
Yeah.
We can't divide the tuber, so lots of people have been interested to see could we take the tuber and divide it up. A bit like a potato, because the tuber is somewhat similar to a potato tuber in the sense that it is a root tuber, stem tuber. But what we can also do is we can do leaf cutting. So this is a nice one. I've never actually done it. It's one of the things we'll do next time we have a leaf up. But we can take some of the pinnae off the leaf here, and we can break them off, drop them in the soil, and amazingly you can grow a new tuber and a new plant from that. Yeah, it seems bizarre. It seems like something you wouldn't do. But yeah, I know Royal Botanic Gardens Edinburgh, they've done it, and at Bonn, and it's something we're very keen to try when our leaf comes up next time.
Okay. The other question is, how rare are they in their natural habitat?
That's a really good question. That's one I'm afraid I don't think I can answer that effectively. What I do know is that the forests of Sumatra definitely have had a lot of logging take place. You know, a lot of them have been replaced with palm oil. It's difficult because obviously Indonesia is equally trying to protect these things. It really does value plants like this because they're great for tourism, they bring in lots of people. But I would say that, you know, with pressures on forest ecosystems, increasingly rare, and it's increasingly important, you know, for people like ourselves to hopefully tell that story and to help where we can, you know. But equally, I think Indonesia recognises the importance of these plants, and, you know, it equally wants to protect them and keep them for as long as possible.
Yeah, great. Is that all the questions?
That is, we have got a couple of comments. One person says, "You're great."
Great.
And someone else says, "Oh, wow."
Good, excellent. Great comments. Well, thank you so much, Alex. I mean, is it going to be 10 years before we see this?
So unfortunately, what we've got is now 2 small tubers. So we've got Tiny's, you know, just a little small tuber.
Yeah.
And I think that this one it'll take quite a lot of energy if it fruits. So, and if we have fruit, then we're looking at 7 to 10 years. So I think what we feel confident of, we will do it again. Yeah. And I would hope that we're looking at the 7 years rather than the 10 years. Yeah. But we wouldn't like to confidently say when that's going to happen.
Fair enough. Well, look, thank you so much for giving us your time today. I think, thank you for all of your comments and questions. I would highly encourage anyone watching this who hasn't been to the Cambridge University Botanic Garden before to come along. It's a spectacular place, and you can meet people like Alex, you never know, and ask them your questions in person. Maybe I shouldn't have made that promise.
No, we will be around today. That's what our aim is.
And we are going to be doing another live stream. It's going to be on Friday at 12 p.m. We'll be going to the Museum of Archaeology and Anthropology to talk to them. I think we're going to get a little tour from Mark Elliott about their Another India exhibition, which is part of India Unboxed, our project celebrating the connections between Cambridge and India. But I think that's it. So thank you very much, and thank you for watching. Bye-bye.
Thank you.